the main event. We've been kind of building with these vectors and these vector valued functions. But then a lot of the AP type stuff is coming from what we do today. Okay? So let's talk about what we remember from Calc AB. Linear motion. So either an object is moving back and forth or an object is moving up and down. What do you remember? If we have position, how do we get velocity? If we have velocity, how do we get acceleration? Okay. If our velocity is negative, what does that mean about the particle? It's moving left. If our velocity is positive, right. If our position is negative, we are to the left of the starting point. If our position is positive, we are to the right of where we started. Okay. Let's see. Can you think of anything else that I've ever asked you in linear motion?
If the acceleration and velocity are different signs, it's slowing down, and if they're the same, it's speeding up, even if they're both negative.
Very good. If we have acceleration and velocity going in the same direction, we are speeding up. Okay. So the benefit to us having vector value functions or parametric equations is we can have a particle moving in multi-directions. Okay, we're no longer stuck with one direction. We can be moving anywhere. Okay, and so that's, and really, if we were given a situation, how many situations can be modeled with linear motion versus how many situations can be modeled with multi-directional motion?
Probably all. Yeah.
Okay. You don't have very many situations where you're just moving back and forth. Okay. You have more situations like this.
That'd be a great roller coaster. Just go up and down.
That's
an
actual
It's
an actual thing.
Okay. A particle moves in the xy plane so that at any time t, the position is given by this. Okay? Now, in this example, what?
light.
It's not a three-dimensional
I
plane.
know.
Three-dimensional space. Okay. So here's my position. We want the velocity vector, we want the speed of the particle, and we want the acceleration vector. Okay? So at least go ahead and write down our set of parametric equations.
So when you're taking like the derivative to like velocity, do you just do like dx or dy dt over dx dt? Or do
Nope. We'll do them separate. So just like we did yesterday with our vector valued functions, and this is kind of a vector valued function. They just didn't write it that way because everything else we're going to give as a vector. Did you have a question, or are you just frustrated?
I'm not frustrated.
Okay, I'm confused. All right, so our velocity. What would our velocity vector be? What is the derivative of x?
T squared plus 8t.
And what's the derivative of y? Just shout it out.
Or
T squared.
Okay, so if I want the velocity vector at time is 1, and we have the vector 11, 1.
That's fancy.
Now, let's talk about the speed of a particle. Okay, this goes right back to what we
Is
did.
that just the magnitude of the velocity?
Okay. So Joe said, is it the magnitude of the velocity? Yes. Yes, it is. Let's talk about how we found speed on your quiz that I will be giving back tomorrow because everyone has taken it now. But on your quiz from Tuesday, if I asked you for speed, we took dx dt squared plus dy dt squared under the square root, okay? Well, if I take the magnitude of velocity, isn't that what I'm doing? Okay, so it hasn't changed. We can now just put it with, it's the magnitude of the velocity vector, and that gives it maybe a little bit more meaning to us, okay? So the speed at t equals 1 would be the square root of 121 plus 1. Okay, and then in part C, bless you, I covered it up, but in part C, I want the acceleration vector at time is 1. Okay, so same thing as Calc AB. Our acceleration is just the derivative of the velocity. We're just going to write it as a vector. So our acceleration vector would be 6t plus 8, comma, 12t squared minus 6t. What? At 1. So our acceleration at 1 would be the vector 14, 6.
Is there like some kind of twist? Like this seems oddly easy.
Not really. Okay, now bear with me. We'll see if this will work. 2plot.com. I don't know. It's been a while since I've tried this, so just bear with me here. We're going to do a parametric equation. Oh, okay. X is... Isn't that cool?
Yeah.
What's our X? T cubed.
It's 4t squared.
And Y?
T to the 4 minus t to the third.
Zero, 2. Okay, so if t begins at 0, this is what we have here. Let's see if I can make my... So... Okay, so there's our curve. I'll make it smaller again. At t equals 1 is right there, our velocity vector. Oh my gosh, what's happening? Oh, I forgot a 4. No, I got my 4. T to the 4. Woo. I have it that it should be going like this, up here. Do I have it typed in correctly?
Do you have to put a space in between the 4 and the s cubed? And the x?
Oh, I bet I have to say times. Maybe not. It's not what it looks like though.
Parentheses.
Parentheses probably let's be honest here.
Parentheses fix everything.
Well, it's a failed experiment. Okay, I'm sorry.
I'm confused.
Yep. Well, ignore me.
Yeah, I graphed it on the calculator and it's showing what they're graphing there.
Yeah, I don't know why I have it written down differently. Okay. Well, our velocity vector at 1 is 11, 1. And our, so here, I can't graph that. 11, 1 would be a very, very large vector. Okay. So at 1, our velocity vector is 11, 1, and our acceleration is 14, 6.
That's what I thought.
Yeah.
Okay. You know what Mrs. Holman was imagining? I was wanting the tangent vector, but that's not what the velocity vector represents. So I was getting myself confused. And if we put like negative 100 here, then we have this part is what I was wanting to see. But we don't have that part because we begin at, that's what I was panicking about. But we begin at 0. So the other part doesn't exist. So I got excited to see the wrong part.
Doesn't it look like the velocity vector should be like 11, negative 1 though, or negative 1?
Yeah.
Because wouldn't that be a positive vector and it's like the slope is down? Or does the velocity vector not match up like that?
The velocity vector is not going to be the tangent vector. Because remember, when we made our tangent vector, we took dy dx and made a vector out of dy dx, didn't
Okay.
we?
Yeah.
Yes.
Okay.
So dy dx gives us our tangent vector, which is different than the velocity vector.
Okay.
So is there any way to see like the vectors that we're calculating graphically?
We would have to draw them on, like, so you could, like, on your graphic calculator look and kind of draw them in. Okay. All right, go ahead and write down that dx dt is t sine of t and dy dt is cosine of t squared. And that at t equals 2, the object has position 1, 4. Okay, what we're going to do, we're going to do a, guess it's not a true AP problem because there's 6 parts to this problem, and you're never going to have an AP problem with 6 parts. But all of the parts to this problem are things that could happen within an AP problem. So after winter break, we're going to talk about polar derivatives and polar area. On your AP test, one of your 6 questions for the free response section will be either parametric or polar. Guaranteed, you will have one or the other. Okay. So if I want the acceleration vector, what do I need to do with dx dt and dy dt? Excuse me. Find their derivatives. So essentially they're giving you the velocity vector, they just didn't write it as a velocity vector. So our acceleration vector would be, what do we have to do? And then for dy dt, our derivative, we have to do the chain rule with. Oh, why did I write cosine again? I meant to write sine. Okay. So our acceleration evaluated at 2. Make sure that you are in radians, please. And I'll let you find this for me. Pre-calc. Algebra 2.
I just find it so weird because like, you used to want to do everything it's like
What do we have for our horizontal component
0.077.
and our vertical component? Okay? Write the equation of the tangent line to the curve.
How did C already get negative with that one? Because of the sign of 4 is a negative number.
It's the same number, just the
It should be positive.
Yeah.
Yeah. The sign of 4 is a
Oh.
negative.
Sine of 4 is negative times
I forgot
negative
to say the
2t.
negative. Sorry. Yes.
Thank you for catching that. How do we write the equation of a tangent line?
dy.
Yes.
Then goes on M.
Point slow.
Okay. Okay. So dy dx, we have parametric derivatives. Dy dx is just dy dt over dx dt. So evaluated at t equals 2 would give you what? Calculate it for me, please.
Because at time t equals 2, the object is at position.
See, it tells us that that's something that I would really
After you're done,
What's the team name?
What's our slope very high?
negative 0.359.
Okay. And what's our y1 and x1?
The little guys they gave us.
The guys they gave us. Okay, so y minus 4 equals our slope times x minus 1. Okay. Yes, this is a rectangularly defined tangent line to our parametric equation, but that's fine. That's how it needs to be. Okay. We can make it parametric, but it's not necessary. Okay. All right, what else could I ask you in a scenario like this? I could ask you to calculate the speed of the vector at t equals 2. Is that the last page?
No.
Oh, okay. You just don't want to move on. You might have to like zero out over here.
What the heck? Why does it do that? Okay, so I was confused because I plugged in the slow and it gave me a different answer than I should have done. And then I plugged
Are
in,
you in radian mode?
yes. And then I went and did it like just by separating all of the different words to solve it. You see an error with rotation?
Yeah, you took cosine of 4 divided by 2 and then
Okay.
multiplied it by sine of 2. Okay, so our speed is the magnitude of the vector, which turns out to be the square root of dx dt squared plus dy dt squared. And if we're evaluating at 2, then we can go ahead and throw 2 in there right away. So we have 2 sine of 2, the quantity squared, plus cosine of 4, the quantity squared, in radian mode. This was a common mistake on our quiz. Some of us did not switch to radian mode for the speed and arc length problem.
That's upsetting.
Mm-hmm. I would say more people did not.
Keep looking at me, it makes me feel way better, doesn't it?
Well, I there were less people who did it in radian mode than there were who did it in degree mode.
I know that's
So what's our speed?
It just sucks because we know how to do it.
What's our speed?
2.081. Or did I do that wrong?
I got one.
Oh, I didn't do the square root.
Yeah, that will make a difference.
Come on, Lily, get it together. I'm a mess. It's fine. Get it together. Oh.
displacement. This is not something that we talked about in our little A-B review. So what I'm going to have you do is take 10 seconds and hash out with the people at your table. How do you determine displacement if you know velocity?
You take the
You take,
See what I did there?
I see what you did.
Yep.
Yeah.
Why are you doing
And then distance is the absolute value.
Yes.
Yes.
Wait, where do you put the absolute value?
Distance is well, this is this.
Okay, here we go. How do we do it? Integral. Okay, I heard some people throwing around the absolute value.
Only if it's distance.
If we're talking about distance, we need that absolute value. But if we're talking, and really we have arc length, right, that we can measure distance with now. And so for displacement, we're really talking about the separate integrals, one for each component. Okay, so we would want to do the integral from 2 to 7 of dx dt. And we would want to do the integral from 2 to 7 of dy dt, so that we can determine the displacement both in the horizontal and vertical direction. So if you have, trying to look at our colors here. If you have a neutral shade of shirt, like black, brown, white, tan, gray, you are finding the displacement of the horizontal component. If you have a non-neutral color of shirt, please find me the dy dt. Yes.
But this is a calculator problem.
It is, so
Yes.
punch it in your calculator.
Yes, I love that.
Well, you could do the first one with integration by parts, but I don't know about the second.
Well, you would still have to use your calculator though, because we don't know like the sine of 7 and the sine of 2.
Well, maybe
Right.
you don't. I don't either. Good to know, Darby.
Thank you.
But I didn't know which one she did. I was like, neutral colors.
I'll just do both of them.
I'm still writing it.
Sorry.
2 7. I don't know. T squared.
I love how the calculator has to think for a
I
while.
don't. That makes me cry.
It makes me feel like
Every time
it's like
we
this
press
is big math.
Mom's
Yeah.
waiting for the camera.
God, why is
I
it
know,
taking so
like,
hard?
this is math the calculator
0.96.
used to think about. I'm gonna send you a post.
Okay, our displacement. Who's a neutral? Hannah, you are neutral.
Yes, I got negative 6.362.
6.362. Okay, my colorful people.
0.097.
Yeah, I did that one right. I don't know, both would be wrong together.
Okay, so from where this,
Elbow.
well,
There we go.
from 2 to 7, this particle moved 6.362 units to the left and up just an itty bitty
Your
bit.
other right. Right.
All right, 2 more parts. Or do you, oh, dang it. I meant to do a different color of marker for each part.
You only have 4.
Come on.
Well, but watch this.
If you
Why
get
is
it
more?
We get a time it points.
Oh my gosh.
Whoa, you get like a peachy color?
Whoa.
That's all we care about.
Whoa. We could do like
Let's get like-
art on the smart board.
That is
art is
smart.
Okay, distance traveled. Let's go back to our arc length concept. How did we calculate arc length?
The integral of speed.
The integral of speed.
I am speed.
Okay, so right now, my 4-year-old is super obsessed with cars of all varieties, like Cars 1, Cars 3, There's something called Mater Tails on.
Mater Tails is where it's at.
I have the
Wow,
cars
babe, you could really hang out with someone's
I think
So-
The cars game for the PlayStation
So my
2 is
4-year-old
really
can find the remote, push the Netflix button, get it to the kids menu, and find Mater Tails. And
He's smarter than I am.
What are you doing? So that
my
reminded
dad
me.
canceled cable on Friday, and it caused our internet to be down the entire weekend.
And he also told me I eat lizards for breakfast. That's what Lightning McQueen says. That's what Lightning McQueen says.
Good job.
Has anyone else ever played the PlayStation game of Cars?
Who hasn't?
Okay, Dave, did you put this into your calculator
It's
yet?
really, it's like Grand Theft
What'd you get?
Auto, but for babies.
I'm
You
so
just
happy
drive
with that.
around.
It's angry. It's still thinking.
Yeah, it's not for a while, but now it says 13.229. Oh, big thinking.
Yeah.
Victoria's angry calculator has given us the answer of 13.229.
Giving you
Okay.
a science paper.
Did you know
Really?
that this
You're asking
calculator
that?
is actually
Francis error.
Oh, what error?
Yes.
Oh, yeah, I'm sorry.
I was writing
These
the code.
calculators actually
Yeah.
Lightning McQueen's quote.
It's pretty
No, I
angry.
wrote Women's for your
Oh.
You're all like just being on the board though. Is it already gone?
No.
No.
This year today. Wow.
You need to be gone next year so
Okay,
that
you're good.
the
So that they can hear this? Oh,
Okay,
Lord.
I feel like your class last year. didn't
If
really
this
care.
is next year, I apologize.
Good
Okay, find the position. Find the position of the particle. Okay, now this is tricky.
No,
It's not tricky?
you just have to
Nothing
integrate
is
the
tricky.
two derivatives we've been given.
Except for because they're not fun.
Did you tell me that you didn't know how to integrate cosine of t squared?
Yeah.
Yes,
But
okay.
that's not
So
one of the
doing this
derivatives.
by hand
It's impossible.
Is going to require different method.
is going to require a different method. Okay, and you're going to have your calculator in your hand. We know some information about
calculus.
We know the displacement or the distance or one of them. Like we know both of them, but I don't know which one we need to know.
I think the displacement would be.
well, we know that coordinate 1, 4, right?
Yeah.
And that coordinate 1, 4 is when t is
2.
okay.
Oh.
So could we take the integral from 1 to 2?
Oh, and then we subtract stuff.
That's why.
Gabe. It's okay.
Okay, and what should this equal?
A number.
Displacement from 1 to 2.
Yes, but if I'm taking the integral from 1 to 2, then it should equal the displacement at 1, 2, minus the displacement at 1. Okay, so I'm going to call this x of 2, y of 2, minus, oh dang it, 1, 4, because we know the position, oh, got that backwards. We know the position at 2 is 1. Minus,
Oh no.
I know, I ruined it.
What happened?
I picked up the eraser and so my color went back.
I almost said something.
It's okay. We will all survive. Do you understand what I'm doing here? Okay? We don't want to take we can't take the cosine of t squared antiderivative. Like, that's not a possibility for us with the tools that we have, even though we have a ton of them. Okay? Our calculator's in our hand anyway. So if we can make it a definite integral and use the fundamental theorem of calculus, we can integrate each of these separately and then subtract over the 1 for the x component, the 4 for the vertical component. Okay? So our position is going to be the coordinate x1, y1. Find this integral, subtract over 1, but then we have a negative here, so we'll have to make it opposite, right? We're solving. I need you to make sure you can get that answer.
Yeah, that's what I got. Wait. The negatives are switched on.
Let's talk about what I.
Oh, that's right. That's right. I see. Because you have to subtract a negative number to add and subtract a positive number to get a negative. That's how I flipped it. Because I just subtracted 1 and 4 from each.
Yes, but then this is a negative that we have to account for.
Multiply.
Okay, this is something that I know last year some of us would forget about, the fundamental theorem of calculus and how we can use it in this setting to find a value. You don't always have to do the plus c and then find the plus c and then plug in the coordinate. Okay, in this case, we could do that for our horizontal component, but we can't do that for our vertical component.
You can't stop me now.
So x1, y1 is the displacement t equals over 2.
That's a position. So at time is 1, we are a little bit left and quite a bit up. And then 1 second later, we get to the position of 1/4. So this particle really isn't moving that quickly.
It's moving though.
So let's work out them. Whose name is that?
Jimbo.
Is this a different one from yesterday? Oh, it's the exact
Wait,
same
so
hand.
the
Wow.
answer is that, not
That's the fundamental theorem of calculus.
What's your question, Gabe?
no, I just was looking at it.
Your question is no.
Still do that.
Okay, so tomorrow our goal will be to do some AP style problems.
Excited.
Okay. For now, I'm going to give you a worksheet for your homework, which you have the next 10 minutes to begin.
This is just like your music.
Yeah, on the back there's some hints for you.
Oh,
Yeah.
it's like, what is it? There's only 4 9 of them are not calculated. Are these kind of problems usually calculator or non-calculator on the AP test? I feel like
Typically, calculator.
okay.